This is Math 3, 4.6 homework notes. Math 3, 4.6 homework notes. That's Unit 4, Lesson 6. We are skipping Worksheet 5. You can cross it out altogether. We're going to be graphing rational functions. So before we do this, I want you to quickly remember when we did these and it was opposite of the inside, outside stayed the same. Do you guys remember that? And the inside was right, left, and the outside was up, down. And the inside was right, left, the opposite, and the outside was up, down, stayed the same. Okay, same concept, but now we're dealing with it this way. I'm going to put a +0 there. Think of this as the inside and that as the outside. Opposite of the inside, outside stays the same. Right, left, up, down. So left 2 from the origin, everything's from the origin for these. Left 2, and I do not go up or down. So I'm going to put a point there. And here is where I'm going to make my new axis. A dotted line this way and a dotted line that way. All right, it's always going to be at that point. So if you went left 2 and then down 3, you would go left 2, down 3, and then make your T shape, your new axis. Okay, this is my vertical asymptote. That is my horizontal asymptote. Remember, all vertical lines stand tall, so their x-men stand tall. So x equals -2 is my vertical asymptote. And why are you sleeping? Why are you laying down is horizontal. Horizontal is y equals, and y equals, did it move? It stayed at 0, so y equals 0 is your horizontal. All right, and after you go left 2, up 0, you will always, from this new fake origin, from here you're going to go whatever the top number is. The top number is 1, so I'm going to go up 1 over 1, down 1 over 1. Always in that direction. If it were negative, then I would go down 1 over 1 and up 1 over 1. It would be these two catty corners. It's always diagonal catty corner like this or catty corner like this. If it's positive, it goes this way. Up 1 over 1, down 1 over 1. If that had been a 2, I would go up 2 over 1. And then I make my graph like this. And this is always the way rational functions look. Okay, so that there is my graph. Find these dotted lines are asymptotes, so that's not part of the graph. That's just there as a guide to say, hey, the graph is never going to touch that dotted line, and the graph is never going to touch that dotted line. Those are called asymptotes. They're going to get really, really close. You can see that dotted line gets close, and that, the solid line gets close to that dotted line, and this line gets close. Same thing with these two arrows on this side. They get close in both directions to the asymptotes. Okay, find the y-intercept. You find that by setting x equal to 0, y equals 1 over 0 plus 2. That is y equals 1/2, because 0 plus 2 is 2 and 1 over 2 is 1/2. Your y-intercept is 1/2. X-intercept, you plug in 0 for y. 0 equals 1 over x plus 2. You could put a 1 under here and cross multiply. 0 times x plus 2 is 0. 1 times 1 is 1. 0 does not equal 1, which means no solution, which means there's no x-intercept. Why is there no x-intercept? Because when I try to solve it, I got 0 equals 1, and 0 equals 1, there's no solution for that. If it was 1 equals 1 or 0 equals 0, you'd have infinitely many solutions. We've talked about that in a previous lesson. But 0 by itself does not equal 1, no x-intercepts. All right, that's pretty much it. All we have left is D and E. And here you state the domain. And domain is going to be all reals such that x cannot equal Now my graph, see, it's all of this and all of this, and there's always a graph on the right side and always a graph on the left side, but it's never going to touch that asymptote. Why? Because that's an asymptote. It's at -2, and it can't ever equal -2 because that's what makes your denominator 0. So it's all reals such that x cannot equal -2, and actually comes from your vertical asymptote. It cannot equal -2. And your range is similar as well. It's all reals such that y cannot equal. See, the graph is going to go up forever and down forever, and it's going to get really close to this horizontal asymptote but never touch it, so y cannot equal 0. And yes, it will always come from your vertical and horizontal asymptotes. It's everything except your vertical asymptote. Your range is everything except your horizontal asymptote, because those are asymptotes. It can never equal those lines. Okay? All right, so next one, I'm just going to graph it with you. We'll do the rest in class. Opposite of the inside, outside stays the same. So 0 on the inside, so I don't move right or left. Outside stays the same, that's -2, so that's down 2. So I don't go right or left, but I go down 2. Put a dot. That's where my asymptotes are going to be. So I'm going to put that in with color pen. So my vertical, remember vertical stands tall, that's x. My vertical, oh, I'm sorry, we're crossing out the last two. I forgot to mention that on both of them. And even on the next page, we're crossing out the last two. Okay, vertical. The vertical is going to be x equals, and it's this one right here, and it didn't move right or left, so x equals 0. And horizontal is y equals, this one's horizontal, and it's y equals -2. And then from the fake origin, the new 0, 0 here, because that top number is 1, I'm going to go up 1 over 1, down 1 over 1, and graph. It always approaches the asymptotes there and the asymptote there. It always approaches on both sides. Okay? That is it for now. We'll finish, turn it in like this. This is what you're turning in for this piece. Number 1, completely done. Number 2, just the graph. Snap a picture, turn it in. You're done with video notes. We will finish it in class, and then you'll turn it in as a worksheet.